I'm Matt Caughley. I'm a civil designer with Bundaberg Regional Council. Myself and Lindsay Dexter. All right, so we were charged with implementing this within Bundaberg Regional Council. I want to elaborate on the reasoning behind BRC's adoption of ADAC as part of the ASCON submission process, as well as identifying the issues BRC faced during implementation. I also want to give you a brief overview of what ADAC actually is. Okay, in the past, the internal ASCON management process was as follows. The 4 construction plans were issued and construction began. If any changes were required during construction, the design change request was required to be submitted by the work supervisor, approved by design, and signed by the project RPQ before the change could take place. Once the project was completed, the asset checklist, which outlined what construction actually did, and marked up paper plans had to be submitted to assets via email. One important thing to note here is that there's no validation through the process. If no one submitted any change requests, if nothing was noted, or if the asset checklist was submitted as per design, then everyone would just assume they could construct it as per design. Here's a good example. Post-flood BRC saw the need for a bund to be created to alleviate flooding during major storm events in this area here. This XP model represents what occurred during a Q100 flood pre-construction. The lighter the colour here, the deeper the flooding. This represents what would happen once we built our bund wall. This has been run through the same XP model, and you can see there's definitely relief from a Q100 storm event. This is the as constructed marked up paper plans on the left. We actually got marked up paper plans back, so you can't get angry at them for that. This suggests that the height of the bund wall is as per design. On the right is a comparison between the design cross sections and the as constructed surface. The as constructed surface is in red. The differences in the top of bund walls are about 150 millimetres. Height, as per design, is particularly important for bund walls. It's also worth noting here that this was only picked up because the designer drove past it on his way back from Gingin. There was a few other things built wrong, so they surveyed the whole area and they found this as a result. This is pre-construction versus post-construction. Run through the same model. It is, Alan, it is worse. I was going to say a lot more stuff but Alan nailed it. It is a rare case. It doesn't happen all the time, but it does illustrate the importance of communication through the project lifecycle. But more importantly, it illustrates a lack of structured as constructed processes. As you saw before, we do have a process, but we also have a paper trail required, and that involves humans. We want to try and eliminate humans from the process as much as possible. And this is where ADAC comes in. It's not the be-all and end-all of the as-constructed data capture management, but it does provide a catalyst for us to rethink the process. So what's an XML? XML is an extensible markup language that can be interpreted by both machine and human. An ADAC XML is an XML that follows the business rules set out by the ADAC XSD. This is a human-readable ADAC XML. This is a XML opened in a notepad, in a reader, like Notepad. It contains all the relevant data for a project, and also shows the type of syntax used to form a valid XML file. Users of the ADAC module in 12D don't have to read this. You can, but you don't have to. They go a long way to provide a less intimidating user interface. Okay, so there's an ADAC XML, and there's also an ADAC XML schema definition, the ADAC XSD. This XSD contains smaller XSDs, including things like transport, water, sewerage, open space, surfaces. All these smaller nested XSDs contain all the ADAC objects and the elements required to identify those objects. It does help to consider the XSD as a file tree in Explorer. So you double click on the ADAC SSD, drill down into the next XSD, which is open space. In this example, we can select something like waste collection point, which is a technical name for a bin. So here's an example of how we, this was, I think, the first iteration of how we created our as constructed workflows. Once the project is complete, as-con information is collected via two sources. One, by the surveyor, and two, from the work supervisor, or what do they call them? ATS operators, sorry. I don't know what that acronym means at the moment. You ask me later after a beer. This information is collected into one valid XML and forwarded to assets for validation. If it's acceptable, it's uploaded into GIS system, where it's then available for us to consume for future design, or available externally via Dolber4U dig inquiries. The first step here is the correlation of the data. The XML file forwarded by the designer, to the designer by the surveyor is not complete. The surveyor can only capture information that's readily available to them. So they can't capture things like pavement depths, concrete depths, pavement types, subgrade types. The surveyors can only pick up what they can see and touch. To help the collection of data by the surveyors, we have the guidelines for creation and submission of ADAC XML files. This document defines ADAC objects, the elements required by council to recognise these objects, and their relationship with other ADAC objects. So using our waste collection point as an example again, we can see it's captured as a single point, and it does have a spatial relationship with other ADAC objects, in that the waste collection point must be within a parent open space area, which is also known as a park, and below that is a description of the elements available to describe the waste collection point. So here there's 4 elements identified by ADAC, and there's only 2 required as mandatory by council. We also have access to the Schema help file. The file provides a description of ADAC objects representing as constructed public works. The help file is maintained and approved by the ADAC Strategic Reference Group under the governance of the IPWAQ. Steps 2 and 3 in our first iteration. Step 2 is where the data gets finalised. So the designer and work supervisor add that extra information we were talking about earlier to the XML. And it also involves validating the XML against the XSD and comparing our data to the original design. The end product of that step is the valid ADAC XML. Step 3 is from the completed ADAC XML, it's possible to prepare long sections of road centrelines, if you need to, road inverts and drain and sewer networks. The completed as constructed file and HTML report is then to be forwarded to Assets Department for validation and approval. Here we've got all of Childer's drainage network. Lindsay was engaged by the Assets Department. Oh, no, that's just the last view, that's all right. Engaged by the Assets Department to capture all this data and provide them with an ADAC XML. So we developed a toolbar to limit the amount of steps our designers had to perform to create an XML. The first step was create the views. The second step was apply our map files and UAF files to the data. Third step is the validation. There's about 635 errors in this, but that is because the survey couldn't capture everything. There's not typically 600 errors in every survey Lindsay does. Joint types and pipe class. You can't pick that up. So that comes through as required. That's a default we set. And so we don't want to change those, and you don't have to change them. It's a trigger to make you aware that they're there. And the next thing is to write out the XML. And we see it clunking away here. A lot of information. And here's our human readable XML. And for the amount of information you're processing, it's incredibly fast compared to having to create long sections of this same information. Our second last step is creating a report, a HTML report. Now that last one was the XML. That's required to be consumed by assets using their software. This is for actual assets, humans, to be able to read. So this contains all the metadata, so the project name, version, ADAC version, 12D version, the surveyor, the time it was surveyed, all the relevant element objects. And you can see here where I've got the cursor, see the defaults for class and joint type come up as required. That's the default, that's the trigger to know that they should be there because BRC is asking for them. And now we've had old school engineers say, I don't like that, I want to see paper plans, show me some paper plans. So we use our plot frames, our PPF to generate long sections of the whole drainage network in shoulders. This makes use of the project details you fill in at the start of the project. And that contains the survey information as well, so your datums, reference marks, scale factors. Again, it's funny, it feels like a long time here, but it's only really been about 10 seconds. And that's our PDF of the drainage network in Childers. You can see a few manholes, you will see a few manholes shooting off into the sky. Again, that's because the default value being -999, so the calculations there send that surface off the page. Okay, so we know what ADAC is, we know what we can do with it inside 12D, but how do we implement it? Firstly, we need to ensure that the data we gave assets was exactly what they needed to accurately cost their assets. They provided us with the minimum elements required to recognise all BRC assets in their software. They use my data. Secondly, we wanted to prove that the process could be incorporated into existing systems. We started with our survey library. Our library contains all the survey codes for assets that are routinely surveyed. We utilised the existing codes wherever possible and added attributes to those codes. We also had to add a few codes. We had to add, I think it was 6 or 7 codes in total, but they were for water-sensitive urban design. And we would have had to add those anyway, as that type of infrastructure is becoming more and more common. It was also important to get external agencies on board and to get them to buy into the changes regarding ASCON. We believe by offering the training and the tools required, we could, at a minimum, smooth out the transition in physical pickup processes. The main change in the field would be a new pickup file with more attributes required. Excuse me. We also had to provide an incentive to supply an ADAC compliant XML as part of the process. For us, this was eliminating the need for paper-based as-constructed plans. As part of the new planning scheme, we will be asking for only a CAD file of the as-constructed plans together with an ADAC compliant XML. It can be seen as a hurdle in regards to data protection. People want to physically hold something and don't believe it if it's digital. But as a way to try to deter any data manipulation, we've also threatened to survey random projects to ensure what has been submitted is true and correct. In regards to efficiencies, for anyone that's ever had to redline these plans, you know how tedious this is, and it's frustrating. I hate it. And with ADAC, you just don't need to do that anymore. Okay, so we're also assisting in capacity building by providing the ADAC data dictionary. So it's an Excel spreadsheet of every ADAC element and every object inside that, and a description of what that element is or object is. All our 12D map files, UAF files, that toolbar we created, the BRC Trimble FXL files, and Lindsay's phone number. So the big three here, the big key lessons for us, we have to ensure ADAC data is integrated into the asset and project lifecycle. We have to maintain a single point of truth for as constructed information, and it had to retain its geometric accuracy. And we also, for anyone else that's planning to do this, you have to ensure a multidisciplinary approach. And it has to be taken during implementation to foster ownership of the processes from stakeholders. If you don't do this, you can implement what you want, but eventually someone's going to whinge that you didn't include them. And if that person's powerful, then it just gets buried. Okay, so future directions, where we want to go. So this is a good example of what used to happen. Someone had a thought, had an idea, put it on paper, generated those plans, and someone got tasked with implementing it. Now we do basically the same thing. With all the technology in the world, we still do the same thing, except we've replaced the physical hand drawing with computer drawing. The final step is being able to do your design, generate anything you need to, any sort of plans from that automatically from that design, give it to implement construction crews, no paper involved, so they can use it for machine control, and then we generate our XML from that information. Recently, last year there was a further inquiry into smart ICT and the role it plays in infrastructure. That's complete now, and there's 10 recommendations made from that. One of them was to require BIM to LOD 500, that's the standard, on all infrastructure projects exceeding 50 million and being funded by the Australian government. If projects start, if that's happening in large projects now, it's going to filter down. So there is a need for this process to start, at least start. Another part of that report stated that the industry recognised ADAC as a successful open source data system. We also want to integrate this into our Dial Before You Dig service. And we need to be able to associate the quality of data we're capturing through the quality level A, as quality level A in AS 5488. The standard provides guidance on how subservice utility information may be obtained and how that information should be conveyed to users. Thanks very much, guys.